Football vs. Physics. The NFL was founded on August 20th, 1920, shortly after the sport of football was created. Football and physics go hand in hand, and I'm going to give you some definitions to help you understand why. The first definition is momentum, the strength or force something has when it is moving. Impulse is the amount of change in an object's momentum, and a collision is an instance of one moving person or object striking another violently. The definition we associate with the most with football would be collision. From the NFL to Milton High, like this one, there's collisions all the time, but these collisions have effects. As you can see from this chart of concussions in sports, 57% of concussions happen in football. It may not seem this way, but physics is actually the reason for all the injuries that happen in sports. The collisions and the momentum of the players result in injury in severely injured players with things like CTE. CTE is caused by repetitive brain trauma. This can happen from years of collisions in sports, and we see this in many pro athletes, especially in the NFL. A prime example of this is Aaron Hernandez. Researchers have found a connection between the violent actions of Aaron Hernandez and the brain trauma he suffered from having CTE after years of playing in the NFL. This does not justify his actions, but it's crazy to think the world of physics has such an effect on not only head trauma, but crimes. The last connection from physics to football I want to make is inelastic collisions versus elastic collisions. A perfectly elastic collision is defined as one in which there is no loss of kinetic energy in the collision. An inelastic collision is one in which part of the kinetic energy is changed to some other form of energy in the collision. As you can see from the diagram, these definitions kind of match the images. In football, there's both. For example, a football deforms when it is kicked. During this deformation, some of the kinetic energy is converted into eternal elastic potential energy. This is an example of an elastic collision. But there is also inelastic collisions, and these would happen in a time like this. When two objects, such as two football players, collide and move together as one mass, the collision is called a perfectly inelastic collision. Since the two masses are moving together, they are technically one mass, which makes it such a perfect collision. This picture is also a great example of impulse. The word momentum is definitely easier to understand than impulse, so I'm going to connect the two words for a clearer definition on impulse. When two players are running full speed at each other in a football field, they build up their momentum. At the point of contact, one of the football players must apply an impulse by hitting the ball carrier in this picture. Impulse is the product of the applied force and the time over which that force is applied. So at the beginning, it's just their momentum, but once they hit the player, that's the impulse. Today I solely talked about how impulse, collisions, and momentum affect football, but there are so many more examples of physics in football. It's so crazy to think how physics not only just affects sports, but our world. So many people enjoy sports, and they probably don't enjoy physics as much, but it is really crazy to think that there wouldn't be any such thing as football without physics. Thank you for watching.